We're going to talk about how the daily motion of the sun changes over the course of a year. So this is an example of the impact of annular motion, and it's related to seasons. We're not quite talking about seasons yet. Right now, we just want to think about how the path of the sun through the sky on any given day changes throughout the year. So figure 1 illustrates the sky as seen from the continental United States. It shows that the sun's daily path in the sky, so it's the dashed solid lines, is longest on June 21st and shortest on December 21st. In addition, on June 21st, which is called the summer solstice, the sun reaches its maximum height in the southern sky above the horizon at about noon. So right there. The figure shows that the sun never actually reaches the zenith for any observer in the continental United States. In other words, the sun is never directly overhead. It's a big surprise to a lot of folks. Over the 6 months following the summer solstice, the height of the sun at noon moves progressively lower and lower until December 21st, the winter solstice. Thus, we can see that the path of the sun through the southern sky changes considerably over the course of a year. All right, let's go through some questions. According to figure 1, in which direction would you look to see the sun when it reaches its highest point in the sky today? Well, it's not the summer solstice, it's not the winter solstice, it's somewhere in between, but the highest the sun ever gets in the sky is going to be when it crosses the meridian. The meridian is that imaginary line that goes from due south through the zenith to due north. So in which direction do we need to look to see the sun when it reaches its highest position in the sky today? You're always going to be looking south from the continental United States, or northern hemisphere more generally. If it is wintertime right now, just after the winter solstice, how does the height of the sun at noon change over the next several months? So winter solstice is when the sun is as low in the sky as it's going to get, and then after that it gets higher, so it increases. So solstice is a word, means sun stands still. So the summer solstice is where the sun reverses from going higher in the sky to going lower in the sky. The winter solstice is where the sun stands still, or reverses its motion, going from lower in the sky to going higher in the sky. So after the winter solstice, the height of the sun at noon is going to increase. Looking forward to spring then. Figure 1 is a reasonable representation for observers in the continental United States. Is there ever a time of year when the sun is directly overhead at the zenith? So looking straight up at noon, and big N-O. The closest the sun gets to the zenith is going to be on the summer solstice, and it is still pretty far from the zenith. All right. During what times of year would the sun rise north of east? That is spring and summer. So the point of sunrise is being north of east. When does the sun rise south of east? That happens in fall and winter. So the point of sunrise is south of east. And directly in the east, that happens on 2 days out of the year. Those are the equinoxes. An equinox means equal night. And so those are fall equinox, first day of fall, and the spring equinox, first day of spring. Or, if you like the fancy terms, the autumnal equinox and the vernal equinox. Alright, we're going to play around in the next part with something that's kind of like a sundial. Another way to think about the path of the sun is the direction and length of the shadow cast by a stick. Or if it were a sundial, this would be the gnomon from the sundial. Does the sun always set in precisely the same location throughout the year? No, it does not. So as we just discussed in the last question, the direction that the sun is setting is going to change, just like the direction of sunrise is changing. So in spring and summer, it's going to set north of due west, and in fall and winter, it's going to set south of due west. It'll be the furthest south of west for sunset on the first day of winter, the winter solstice. It'll be the furthest north of west on the first day of summer, the summer solstice. All right, to our sundial. Figure 2 shows a small vertical stick which casts a shadow while it rests on a large piece of paper or poster board. You can think of this to be somewhat like a sundial. For 2 different days of the year, the end of the shadow has been marked with an X every couple of hours throughout the day. Although the sketch is somewhat exaggerated, these shadow plots indicate how the position of the sun changes in the sky through the course of these 2 days. The following questions are designed to show the relationship between between figure 1 on the previous page and figure 2 above. All right. So what do the X's in the shadow plot represent? Represent the end point of shadow cast by the stick. So approximately how much time went by from the time one of the X's was drawn until the next X was drawn for each shadow plot. So it's 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. So it's going to be a little bit under 2 hours for each of those. Talking roughly, say about 2 hours. So approximately how long did it take to create each of the shadow plots? So speaking roughly, about half of a day, the time when the sun is up. And how does the direction of the stick shadow compare to the location of the sun at the time each X was drawn? So to cast that shadow, the sun has to be in the opposite direction. All right, so if I have a shadow that's extending to the northwest, that is coming when the sun is in the southeast. Using figures 1 and figure 2, figures 1 and 2, in what direction would the shadow of the stick be cast on the poster board if the sun rises in the southeast? So the sun is rising over here. It's going to cast a shadow off of the stick into the northwest. Clearly circle the X for the shadow that corresponds to noon for shadow plot A and for shadow plot B. And so noontime is going to be when the sun is south. The opposite of south is north. So we've got that one and that one. Question 12. Compare the position of the X that corresponds to noon for shadow plots A and B. Which shadow plot, A or B, corresponds to a path of the sun in which the sun is highest in the sky at noon? Explain your reasoning. All right, so when the sun is higher in the sky, the length of the shadow is going to be shorter. So higher sun means shorter shadow. So shadow plot B has the higher sun at noon? Which shadow plot, A or B, most closely corresponds to the sun's path through the sky during the summer, and which is going to correspond with the winter? Label these paths on figure 2. All right, so in the northern hemisphere, the sun is going to be higher in the sky in summer and lower in the sky in winter. So longer shadow at noon is going to correspond to winter. And the shorter length shadow cast at noon is going to correspond to summer. Based on the shadow plots in figure 2, during which time of year, summer or winter, does the sun rise to the south of east? Winter. Because rising south of east is going to give me a shadow that is north of west. If shadow plot A corresponds to the path of the sun on the day of the winter solstice, is it possible that there would ever be a time when the stick would cast a shadow longer than the one shown along the north to south line that indicates the sun's position at noon? So is there ever going to be a time where a shadow is cast that's longer than that shadow? And, well, yes, that one is longer. You can get a very long shadow when the sun is low in the sky. So the shadow is very long at sunrise, sunset. All right, let's go on to question 17. If shadow plot B corresponds to the path of the sun on the day of the summer solstice, is it possible that there would ever be a time when the stick would cast a shadow shorter than the one shown along the north to south line that indicates the sun position at noon? All right, so make sure you get the wording right. Is it possible that there would ever be a time? And the answer is no. If I wanted to have a shadow cast that is shorter than the distance from the stick to the noon cross point for shadow plot B, if that is indeed the summer solstice, that is the shortest shadow that could be cast. If I wanted to have a shorter shadow than that, I would have to be at a different latitude than I meant to make this shadow plot. Okay, so no. And that is the highest the sun ever gets in the sky. And make sure we understand our asymmetry between the answers of 16 and 17. The day of the winter solstice is when the sun is lowest in the sky at noon, but that is not when the sun is lowest in the sky. The sun is lower right at sunrise or sunset, for example. The summer solstice, that is the highest the sun ever gets in the sky. That happens at noon, and it cannot get higher than that. All right, question 18. If you were to mark the top of the stick shadow with an X, where would the X be placed along the north-south line to indicate the sun's position at noon today? Clearly explain why you placed the X where you did. So I am recording this. We are past the spring equinox and headed towards the summer solstice, but we're not there yet. So obviously I'm between those two circled X's, and I'm going to be closer to the one on shadow plot B. Will the stick ever cast a shadow along the north-south line that extends to the south of the stick at noon? Interesting question. Could I ever do this shadow plot experiment and find that the shadow goes that way. No, I cannot do that. Not from the northern hemisphere and the continental United States. We are above the tropics region, and so the sun is never going to be in the northern half of the sky. You have to be in the northern half of the sky to cast a southward facing shadow at noon. So is that ever going to happen? A big no. And explain why. The sun at noon is always in the southern sky. It's never in the northern half of the sky. It's always in the southern half of the sky. Is there ever a clear, no clouds day of the year in the continental United States when the stick casts no shadow? If so, when does this occur, and where exactly in the sky does the sun have to be? And the answer to this is no. There is never a day in the continental United States when that happens. And the sun would have to be at zenith. It would have to be directly overhead to cast no shadow from that stick or the gnomon. So sun never reaches